Welcome back, focused learners, to another explainer. Man, I am absolutely thrilled to have you here today because we're tackling one of the most fascinating and literally the fastest evolving spaces in tech right now. We are going to completely demystify the architecture of AI agents. If you've been hearing the word agents thrown around constantly and kind of wondered, how they actually work under the hood, well, you're in the right place. We're going to take a really structured, blueprint approach and break down exactly how these sophisticated systems are built.
Okay, let's dive right into this roadmap. First up, we're going beyond basic chatbots, then looking at the anatomy of an AI agent, and checking out implementation strategies. After that, we'll compare OpenAI versus LangChain, talk about failures and metrics, and finally, wrap it all up with enterprise agents.
All right, part one, beyond basic AI chatbots, from talkers to doers.
So we're seeing this massive, fundamental shift right now from talkers to doers. But before we get totally lost in the solution, we have to ask ourselves a really critical question. Why do we actually need AI agents in the first place? Like, what specific problem are they solving that our standard models just can't?
Well, think of traditional large language models as amazing talkers. They generate text, they give you basic answers, they're great at that, but they really struggle to reliably perform complex tasks over time. Now, AI agents, these are the doers. You need them when your tasks require dynamic decision-making, using external tools, and running multi-step workflows. If you need to integrate with external systems and run long, complicated processes, standard models basically hit a brick wall. Agents, they break right through it.
Moving on to Section 2, Anatomy of an AI Agent, the building blocks.
Just to make sure we're all entirely on the same page here, let's look at this authoritative definition. An AI agent is a system that can perceive information, reason about a task, plan actions, use tools, maintain memory, and execute actions to achieve a goal. Notice the active verbs I'm using there, right? Perceive, reason, plan, execute. This is exactly what elevates an agent way, way above a simple automation script. It's totally dynamic and strictly goal-oriented.
Breaking that definition down into the actual core components, we get this really fascinating architecture. Right at the center is the LLM, but here it specifically acts as the reasoning engine. You can think of it as the brain of the operation. Then you've got memory, which can be anything from short-term conversational context to massive long-term vector databases. You've got the planner to map things out, the executor to actually get things done, and tools. Tools are basically the hands of the agent, letting it physically interact with the outside world. And finally, the observation loop, which lets the agent actually see the results of what it just did and adjust its course on the fly.
All right, Section 3, Agent Implementation Strategies, the blueprints.
One of the most foundational blueprints you'll see is the ReAct workflow, which simply stands for Reason plus Act. The logic here cycles dynamically. First, the agent generates a thought about what to do next. Second, it takes an action. And third, it gathers an observation based on that action. It'll just keep cycling through this thought, action, observation loop dynamically until it hits a final answer. This strategy is absolutely incredible for improving transparency and heavily reducing hallucinations, mostly because the model is constantly grounding its thoughts in real-world observations.
Let's ground that abstract loop with a highly specific, everyday kind of example. Imagine you ask, what's the weather in Pune and should I carry an umbrella? Check out the logic flow here. Thought, I need current weather info. Action, call the weather API. Observation, rain expected with 80% probability. Thought, okay, high chance of rain. Final answer, carry an umbrella. If you're a developer, you can probably instantly visualize the underlying Python code here. It's essentially just a while not done loop that passes the reasoning prompt to the LLM, triggers a tool, observes the result, and updates the context until the goal is totally met.
Now, what's really interesting about this next strategy is how it contrasts with that tight ReAct loop. This is the plan and execute strategy. Instead of thinking and acting one single step at a time, this architecture splits the job up. A planner agent maps everything out from start to finish, so taking a goal like creating a travel itinerary and generating a comprehensive step-by-step plan. Only after that does the executor agent get to work, handling tasks like searching flights and hotels independently. It's fantastic for better long-term planning, and it keeps the LLM from getting totally overloaded with too much context all at once.
Which brings us to Section 4, OpenAI versus LangChain agents, choosing your framework.
Let's look at OpenAI function calling first. I want to walk you through this structured JSON response. First, you set up the tool, say defining a function like getWeather and specifying that it needs a city parameter as a string. Then you get the model's response. Notice something really critical here. The model itself does not execute the tool. No way. It simply safely and predictably formats the request, returning a JSON argument like Pune for the city. Then, your actual application code takes that perfectly formatted JSON and makes the real API call.
So, the crucial point is knowing exactly when to use which framework. OpenAI functions are absolutely ideal when your workflow is predictable, deterministic, and you need really strong enterprise governance and security. It's definitely the lower risk option. On the flip side, LangChain agents really shine when you need multi-step reasoning where the tool selection isn't known in advance and you need those complex, highly dynamic loops. Basically, you're trading a bit of predictability for a whole lot of flexibility.
All right, Section 5, Failures and Evaluation Metrics, the reality check.
Okay, reality check time. Here are the core failure modes you absolutely need to watch out for. Agents can and will hallucinate actions, like trying to call tools that don't even exist. They can fall into infinite loops, just endlessly trying the exact same failed API call. You might see incorrect planning, tool misuse, or memory corruption, where the agent just totally loses the plot of the conversation. Guys, I literally cannot overstate the dangers of infinite loops and memory corruption when agents run unsupervised. An agent stuck in a loop will happily burn through your entire monthly API budget before you've even finished your morning coffee.
Let's move to the next part and see how this builds into our evaluation. Because of those wild failure modes, we have to measure success using hard metrics. You can't just look at whether the text sounds nice, you must rigorously track task completion rate, goal success rate, tool accuracy, and the actual quality of the reasoning. And from an engineering perspective, you have to strictly monitor latency and cost, especially when you've got agents cycling through multiple loops before delivering an answer.
And finally, Section 6, Designing Enterprise AI Agents, the grand finale.
All right, this is the overarching blueprint for an enterprise-grade agent. Notice how the flow changes here. It starts with the user input hitting a planner. Then it moves into tool selection and execution. But, and this is key, notice step 3, memory and reflection. The agent actually pauses to reflect on what it just did, checking its own work against the memory of the user's original goal. Finally, there's a verification layer before the final answer is returned. That reflection and verification strategy, that is exactly how you ensure true enterprise-grade reliability.
Let's tie the whole shebang together with a specific scenario, an enterprise AI travel assistant. Now, we're not using just one agent here, it's a full multi-agent system. We have a planner agent delegating tasks to a specialized flight agent, a hotel agent, and an activity agent. They all share a central memory layer. Plus, a verification agent double-checks the entire itinerary. But most importantly, check out that last critical step, a human approval workflow. For critical or expensive actions, like, actually booking a $5,000 flight, the agent pauses and waits for human approval. That right there is enterprise safety in action.
So, we've covered the components, the frameworks, and those all-important safety layers. This technology is no longer just theoretical. It is absolutely ready to be built. So, armed with these blueprints, I leave you with this one final thought. Will you design the next great enterprise assistant or just a really, really expensive infinite loop? Keep learning, keep building, and I will see you in the next explainer.